Welcome to the video lecture series on principles of compiler design. In today's video lecture, we'll be learning about principal sources of optimization. So there are various subtopics which is connected with principal sources of optimization. So what is optimization? First, optimization is actually reducing the time and space complexity of the code. So that is called as optimization. So in order, we are actually trying to improve the code in order to run it efficiently. So that kind of technique or mechanism is called as optimization. Now this principal source of optimization comes under 6 broad categories: common sub-expression elimination, the second is copy propagation, third is constant folding, the next one is dead code elimination, the fifth one is called as code motion, and the last one is called as induction variable elimination or index variable elimination. So just we will focus on common sub-expression. So what is meant by common sub-expression? Say for example, if you have an expression, two identical expressions, but the value actually is same, the value does not change, then that is called as common sub-expression. So evaluating such kind of expression 2 times or 3 times is actually an inefficient procedure or inefficient process. So such kind of statements has to be eliminated. So for instance, here you can say that a equal to a plus b, b equal to c minus d, and again x is equal to a plus b and d equal to c minus d. Okay. Now when you just closely observe the first and third statements, okay, it seems to be similar, but understand that a plus b in the first statement and a plus b in the third statement is totally different, because a is getting updated in the first statement. We have a statement called as a equal to a plus b. In that case, a is getting updated, and a plus b on the first and third statement will not produce any identical results. But when you take the second and fourth statement, b equal to c minus d and d equal to c minus d, okay, this will actually give you the same result, because c and d values never get updated and it will give the same results. In this case, so what I am trying to do here is actually we will replace the second statement here. So we will replace the first statement. Simply we will take b value and assign to that to d value. So you can see in the first statement d equal to b. So I just take the result which is available in b and assigning it to d. So there is no need to evaluate once again c minus d. So this is called as common sub-expression elimination. So such kind of elimination actually improves the efficiency of the code. Now when we talk about the next topic is called as copy propagation. So what is copy propagation? So when you have same values available in multiple variables, so such kind of statements should get eliminated, because it's actually occupies a space constraint here. So there is a space constraints, and which occupies more amount of space will actually leads to inefficient mechanism. So now we have c equal to a, so a is assigned to c, next c is assigned to b, and finally I take this b value and add it with 10, I store it in x. So when you see this statements, 3 statements, a, c and b are having identical values. So instead of having same value in 3 different variables, directly what is the original value? Original value is available in a. So directly I can add a with 10 and store the result in x. So that's what it has been done here. X is equal to a plus 10. So this is called as copy propagation. Copy propagation should get eliminated. The next is constant folding. So what is meant by constant folding? So when you have an expression which actually results in a constant value, then it is meaningless to evaluate such an expression, because it always results in a constant value. So why you have to unnecessarily waste the computational time in that? So when you take up an expression pi equal to 22 by 7, we all know that this 22 by 7 always results in a value called as 3.14. So there is meaningless to evaluate this expression 22 by 7. So I directly substitute this 3.14 in pi. So unnecessary computational burden will get eliminated by doing this. So this concept is called as constant folding. The next is called as dead code elimination. So if a variable is alive and if it is not used frequently, then the code is called as dead code. Okay. Now, what is mean in this case, when you have temp is assigned with a value called as a, then x is equal to a plus b and y is equal to a plus d. Okay. Now, when you take up this, temp is actually unnecessarily storing a value of a, because subsequently all the expressions use a value, does not use temp value. So, such kind of statement has to get eliminated. So, temp is actually removed here by resulting in the next two statements. The first statement is getting removed here. So, we have x is equal to a plus b and y equal to a plus d. So, having a temporary variable here is an useless statement here. So, we are eliminating that. Now, what is meant by code motion? If a statement gets repeatedly executed inside a loop and the value does not change, okay, then such kind of statement should actually move outside of the loop. So, this concept is called as code motion. Now, when you take up this for loop here, for actually spans from 1 to 5, and inside this for loop I have two expressions, x is equal to a plus b and c equal to c plus d. Okay, but when you closely observe these two statements, x is equal to a plus b will always result in the same value because a and b value does not change. Okay, but when you focus on c and d, c value keeps on updating inside the loop, isn't it? So every time when the loop iterates, every time c value is getting incremented with some segment of value. So you cannot c equal to c plus d have an impact inside the loop. But when you take x is equal to a plus b, it does not have any impact because it evaluates in the same value, through the same value. So we will just try to move that outside of the loop so that it will execute only once. Okay, so that's what has been done in the transformation. So x is equal to a plus b is moved here, x is equal to a plus b is moved here, and then we have c equal to c plus d inside the loop. Okay. So this concept is called as code motion. So the last one is called as eliminating the induction variable, or otherwise it is called as reducing the strength. So what is meant by eliminating the index variable? So we have an expression t equal to 4, I is actually spanning from 1 to 5 and t equal to I star t. Now when you closely observe this, finally inside the loop t value will finally get a value called as 20. Okay, but what is induction variable elimination? Induction variable elimination means index variable I should get eliminated, but it should not affect the result of the program. So how to eliminate that? For example, so final value is t value is 20. Okay, so what I am trying to do that is I directly initialize t equal to 4, then t is less than or equal to 20, and inside the for loop t is incremented by t equal to t plus 4. So this is nothing but I try to print t finally. Okay, this is nothing but trying to print t. So when you just closely observe this, t value will be evaluating to 20 and then it will stop. And finally what we have done is we have eliminated I value from this. So that concept is called as induction variable elimination. So thanks for watching the video. Have a good day.